The easiest sort to implement is called the bubble sort. In a bubble sort, we iterate through each item in the list one pair at a time, and if that pair are in the wrong order, then we just switch them. We repeat that process so long as a switch occurred the previous time we went through the list. When no switches are required, then that means the list was sorted. So here on line 0 is our original list in some random order. To get started, we compare the first pair, and it's already in the correct order. 3 is less than 7, so we do nothing. Then we compare the second pair. 7 is not less than 6, and so we switch them. We replace the 7 with 6 and the 6 with 7. And that's why we see 6 at that spot after the entire run of the list is complete. The way a bubble sort works, as I'm describing it right now, each item will only ever move forward by one spot, but it might move backward by several, which we'll see next. In fact, we'll see it right now. We then compare 7 and 1, but 7 is greater than 1. So we flip them and replace what was then 7 with 1 and the 1 with 7. And again, that's why we see 1 right here. We now compare 7 and 9, and sure enough, 7 is in the right location relative to 9, so they don't switch. And that's why we see 7 in that spot in the next row. We then compare 9 and 8. They are in the wrong order, so we flip them. And so that's where 8 is next. And because we know that the list is the numbers 0 through 9, we can already anticipate that 9 is going to be the bigger number in every remaining comparison. So 9 is greater than 5, 9 is greater than 0, 9 is greater than 2, and 9 is greater than 4. So each time we do those comparisons, 9 is going to move one more spot to the right. And sure enough, at the end, 9 is now the last number. So now our question is, were any swaps required in that row? Well, yes, several were. And because swaps were required, we know that the next list is not necessarily fully sorted. It could be, but it doesn't have to be. So now we start at the beginning and run it again. 3 is in fact less than 6, but 6 is not less than 1. So we flip them, and that gives us 1 in that spot in the next row. 6 is less than 7 though, so no switch there. And 7 is less than 8. So for right now, those seem to be in the right order. And as a result, 6 and 7 appear down there as well. Now we know we already put the 9 in the right place, and we know 8 is the next biggest number. So we can anticipate what happens next. 8 is bigger than 5, 8 is bigger than 0, 8 is bigger than 2, and 8 is bigger than 4. So it's going to keep hopping until it reaches its right location. And as a result, here's what our list will look like next. And that gives us the list on line 2. Now you might notice that after running the bubble sort once, our last number is now in the right place, and after running it twice, our second to last number is in the right place. And that pattern will actually continue, to a decent extent at least. After running the bubble sort on the next row, 7 is going to end up coming to its right location. And there were a couple intermediate swaps as well, like 1 and 3 swapping at the beginning. But most importantly, now the third to the last number is in the right location. But there were swaps on that row, so we run it again. And after the next run, 6 is in the right location. But swaps were necessary, so now we run it again, and now 5 is in the right location. Now next, something weird happens though. After putting 5 in the right location, 4 was already in the right location. And so when we run it again, 3 is going to go ahead and be moved to the right location. The 4 and the 5 match up, because 4 just coincidentally happened to be in the right place after moving 5 into the right location. And in fact, the same thing happens here with 2. After moving 3 to the right location, now 2 is just in the right location. And so our last swap from row 6 to row 7 is just a swap 1 and 0 back and forth. After we run that, we run the bubble sort on line 7, but each individual pair is correctly placed. And so we have no more swaps necessary, and it's done being sorted. The benefit of bubble sort is that it's actually pretty easy to write. It's effectively, for each number in the list, swap it if it's greater than the next number, and keep a running Boolean that says true if any swaps were necessary. You reset that Boolean to false at the end of each execution, but rerun the bubble sort if it was true at the end of the execution. The drawback of a bubble sort is it's actually pretty inefficient. A lot of swaps were necessary. So it's probably the easiest sort to implement, but it also operates in an inefficient time, O of n squared.